derivative equals to 0, then that means at that point we have a horizontal tangent line. So let's write it down. So f of x has horizontal, please take good notes as always, horizontal tangent, which means, by the way, what does it mean, horizontal tangent? That means that your actual graph has either the maximum or a minimum at that point, whatever the point is. So, next. What happens when the derivative is greater than 0? Come on, you know it. Exactly, the function is increasing. The slope is positive, and obviously when the slope is always positive, that means the function is increasing. Now, what happens when the derivative is less than 0? Well, obviously, your function is decreasing because the slope is always negative. Now, it says changes from positive to negative. What does it mean? The derivative changes from positive to negative. That means your graph, the actual function, is increasing first because the derivative is positive. Then, all of a sudden, it becomes negative. So the derivative becomes negative. So that means your function starts decreasing. So the derivative changes from positive to negative. It means that there is a relative maximum. Why maximum? How come not minimum? Well, think about this. The derivative is positive, so that means our function is increasing. And then you reach some kind of point, and then derivative becomes negative. That means your graph starts decreasing. So what happens at this point? Maximum, relative maximum occurs, right? So I'm going to go back to my first page, and I'm going to say that there is maximum relative, sorry, there is a relative maximum. Okay, and obviously when the derivative changes from negative to positive, your function is decreasing first, then starts increasing. That means there is a relative what? Yeah, minimum. All right, so hopefully that makes sense. And I don't really think it's that hard. Now, here you have the graph. Actually, I'll try to, I'll pause it for a second and I'll copy the graph. Okay, done. Now we have a graph of f of x, just a regular function, and we need to try to sketch the derivative of f prime. Okay. Well, I always start with the relative maximum minimum. Okay, so we have actually 3 terms here, so 3 relative maximum, well, let's see, 1 relative minimum and 2 relative maximums. So here's the first point right here, relative maximum. So what happens at that point? What happens to your derivative at this point? When you reach that maximum, relative maximum, the derivative, remember, the derivative is the slope. The slope is the derivative. So what happens to your slope? What's the value? Exactly, it's 0. So the derivative at that point equals to 0. What's the x-coordinate here? I think it's -4. All right, so at x equals -4, the value of your derivative is 0. So we got the first point. Now we have another relative extrema, we call it. So it's minimum right here. And at this point, again, the derivative, the value of the derivative equals to 0. So what x-coordinate do we have there? So I think it's 1. Okay, so when x equals to 1, the derivative equals to 0. And we have one more turning point, and that's the maximum point. And again, the derivative at that point equals to 0. And I think the x-coordinate is it 4 or 5? 5. 1, 2, 3, 4, 5. So 2, 3, 4, 5. So right here at 5, you'll grab the graph of f prime, again crosses the x-axis. Why? Because it's a maximum point and the derivative, the value of the derivative, equals to 0. Okay, now let's see. What happens to your actual graph from, okay, here's the interval, from negative infinity and all the way to negative 4. It's increasing, right? It's increasing. So if your actual function is increasing from negative infinity to negative 4, what is going on with your derivative graph? The derivative has to be positive, right? Because the actual function is increasing. Okay, so the derivative is positive. Negative infinity all the way to negative 4 is positive. So that means your graph of the derivative has to be above the x-axis because the y values, y prime, are positive. Okay, so well, it's not going to be a perfect graph, and we don't really know exactly what it looks like, but we can sketch something similar to the actual f prime. So let's see. It goes from negative infinity to negative 4. Your f prime is greater than 0, so you're above the x-axis. Then you cross it because the derivative changes its sign from plus to minus, and that's why you get this maximum point right here. Okay, now at some point we have to turn. Now what happens between negative 4 and all the way to 1? Your function is decreasing. So between negative 4 and 1. So that means the derivative graph has to be below the x-axis. So this is the only way I can actually sketch it. Okay, and I do need to turn because of what happens at this point right here. The relative minimum occurs. And when does that happen? When the derivative changes from negative to positive. Okay, so that's why we turned, and we have to go through the x-axis at x equals 1. All right, let's continue. Our graph, the actual graph, is increasing from negative 1 to, what is it, 4? From 5, actually, it was 5. From negative 1 to 5. So it's increasing. That means the derivative graph has to be above the x-axis between negative 1 and 5. So somehow you want to turn, and again, why we turn? Because we want to go through the x-axis again. Why is that? Oh, because what happens at x equals 5? At x equals 5, you get another relative maximum. And that means your derivative changes from positive to negative. Now, look at these graphs. The polynomial function. So we got how many turns? I'm looking at the actual f of x. 1, 2, 3. If we have 3 turns, that means you get, what kind of polynomial? Well, 3 turns plus 1, so the degree of your polynomial is supposed to be 4. So it's going to look like this. F of x equals, I don't know what the coefficient is, I'm just going to put a. Ax to the power of 4, and so on. Now, think about this. When you take the derivative of this polynomial, remember the power rule? You take this 4, bring it down, you get 4a, but x to the power of what? 3, right? And so on. So that means your derivative graph is going to have how many turns? Take the degree, highest degree, and subtract 1. You get 2. There you go. You got 2 turns. All right, let's continue. All right, so now they give you the graph of f of x. Next page. And it says, answer the following questions about the derivative of this function. It says, number 1, approximate the value of f prime of, I think it's 4 or negative 4. 4. What does it mean, f prime of 4? What's the meaning of this? And I hope someone said, oh, that means the slope at x equals 4 equals, and that's what we need to find. Basically, we need to find the slope, approximate the slope of the tangent line at x equals 4. All right, so where's 4? So 1, 2, my graph is not that perfect. So 3, 4, somewhere here. So that's the point. So if I draw a straight line, tangent line, that's what I'm going to get. Well, I don't really know what it is. I can't guess, but they're actually being, well, nice here and then trying to help you. And I don't know if you noticed, they give you actually several points. So 1 point here, the maximum. There's another point down here, I see. So now, if it says approximate the value of f prime of 4, that means you don't really have enough information to find the slope of the tangent line. Really, we don't have any equations, nothing. So, and we don't want to estimate just by looking at this line. But what we can do, because they give you a bunch of points, we can actually find the slope of this, the slope of this secant line. Do you remember what the secant line is? It connects the 2 points on your graph. So whatever that slope is, it's going to be, we can say that it's approximately the same as f prime of 4. We're allowed to do that when it says approximate the value. Okay, so that means you're looking for a slope of the secant line. All right, so I'm going to say f prime of 4 equals, first of all, let's pretend it's the free response question, so we need to show our work. So we'll say equals the slope of the secant line passing through, okay, so what coordinates? 3, comma, -1, I think. Yes, this point right here. 3, comma, -1. And the second point up here looks like it's 5, comma, 4. All right, so that means f prime of 4 approximately equals to y2 minus y1 over x2 minus x1. So I would say -1 minus 4 over 3 minus 5. And we get -5 over -2, which is 5 over 2. Okay, so that's the approximation of f prime at 4. Question number 2, and we refer to this same graph, by the way. At what value or values of x is f prime of x equals to 0? All right, 1 second, freeze. What does it mean, f prime equals to 0? What does it mean? That means that, exactly, that means that there is a horizontal asymptote, right? It's a horizontal, the tangent line is a asymptote, I'm sorry. That means that the tangent line is the horizontal line because the slope equals to 0, right? When does that happen again? When we get what? Exactly, maximum, relative maximum or a relative minimum. Right? So that's when it happens. So let's look at this graph of f of x. So we have 1, 2, 3 relative extrema, we call them. So 2 maximum and 1 minimum point. So, and that's where your tangent line is horizontal. So we want to show our work, and we say if f prime of x equals to 0, then f of x has relative, I guess I'm tired already, then f of x has a relative maximum or minimum, which occurs Where? At x equals, well, looks like negative 4, 1, and 5. I think I'm right. Am I? Hopefully. X equals 1 and x equals 5. All right. Question number 3. On what open interval or intervals is f prime of x less than 0? Again, one more time. When does that happen? Yep, when your actual function is decreasing. All right, so let's see. That happens where? Well, starting here, I think it's negative 4, and it goes all the way to this point, which is x equals 1. So we can tell that f prime is less than 0 when less than 0, then f of x is decreasing. And where does that happen again? Negative 4, comma 1, but I think we have another interval. Yep, it starts here and